let's begin. In this part, first, we're going to see some examples of typical word problems questions. That is, questions that have a lot of text. It's a long text that you need to interpret and represent using equations so that you can solve some unknown. Okay, usually you define the unknown in the question as your variable, and then by solving the equations you just wrote, you can determine the value of the variable. So you can mark your correct answer choice. So let's see some typical examples. Let's begin from the most basic ones. The sum of three consecutive integers is 72. What is the largest of these three integers? Okay, so let's try to participate. Okay, all of you have the chance now. As usual, you can let me know what your answer is using the chat, for example, right? Or you can just say it aloud. So let's see. Okay, we'll consider for this question just 1 minute. So you can try. How can we represent three consecutive integers? Well, one possible way is to say that, you know, they are like x plus 1 and x plus 2. Those expressions represent three integers whose difference is 1 unit, you know, to the next. It is true that if we propose an equation such as this, for example, the sum of these three equals 72, we can find x and then find the answer. But what if instead, you know, we follow this approach? Since we want to find the largest of the integers, then let's define the largest as x. If we do that, then what would be, you know, this would be our unknown actually. What would be the two other integers, the two previous ones? So it would be something like this. This is x, x minus 1, x minus 2. So this also represents three consecutive integers of which the greatest is x. Okay? On the contrary, if we propose this, we're saying that x is the least of the three integers. What happens if we add this up? If we add these three integers, the sum equals 72. And you know, solving for x, 3x minus 3 equals 72, 3x equals 75. And thus, x, our unknown, is directly 25. What's the advantage of this? Once you have formulated a variable, you know, for exactly the unknown, then the answer to the question is also the solution to the equation. You don't need to do any further transformations. Well, sometimes this is useful, but it's a good principle. Try to define as your variable for the equation, as much as possible, the unknown, the quantity that you want to find out, okay? Now, let's try example 2. You can try this one. One number is 3 times another number. If they sum to 44, what's the larger of the two numbers? Let's see. Okay. So, all right. So, now, two persons agreed, and the answer is good. Okay, so here the correct answer would be 33, right? Yes. How come? Well, for example, you can say that there is one number 3 times another number. Okay, to make this easier, take a look. I could always define that, for example, one number is, for example, a W. And since this is 3 times another number, this is W over 3. That's one possibility. But another would be to say that if one number is 3 times another, this other number, the lesser one, is actually x. And this one, the one greater than the other, would be 3 times x. So which is more convenient? The sum of the two would be 44. Work with x or work with w? Actually, it is much better to work without messing with denominators unnecessarily. So this one would be a better equation to formulate because it's faster to solve. If you just, add this, then you know that x equals 11, of course. But this is not the answer to the question because x is not our unknown. X is the lesser number. The unknown is the larger of the two. So it would be 3 times x. So the correct answer would be 33. 3 times 11. Okay, so let's take this into account. In order to save time, let's pick our variables wisely. Example 3, what is a number such that the square of the number is equal to 2.7% of its reciprocal? Okay, can try this one as well. Now you might probably use your calculator at this one, right? But how do we formulate this? This says, what is a number such that the square of the number? Okay, what is a number? Let's define our unknown. This is some number, which we may call x. And it says that the square of the number, and we can represent this using x squared, equals to 2.7 of its reciprocal. So take a look. You can say that x squared is equal, interpreting word by word, to 2.7%, but that is to say 2.7 over 100 times the reciprocal of the number. What is the reciprocal of a real number? It's always 1 over the number. So we have this. But now it would be very convenient to get rid of the decimal, right? Here, multiplying by 10 up and down, what we get is this, 27 over 10 cubed, that is 1,000, and 1 over x, and this equals x squared. But what if I multiply both sides by x? So I get rid of this. And so this equals, 27, or you can say x cubed, if we read from the right, x cubed, that is this product, equals 27 over 10 cubed. Now you just take cube roots on both sides, right? X would be the cube root of 27 over the cube root of 10 cubed. So this is actually 3, and the denominator would be just 10. So 0.3, the answer to the question, all right? Let's see another example. Albert is 7 years older than Henry. In 5 years, Albert will be twice as old as Henry. How old is Albert now? Okay, you can try this one. All right, people. So this question. Albert 7 years older than Henry. In 5 years, Albert will be twice as old as Henry. How old is Albert now? Okay, we have several choices. Some people like to define, just one variable. Say, for example, okay, since I want to know what is Albert's age, I can define, Albert's age as my variable or some other variable, okay? For example, what if I say here that this guy is age is X? Since he's 7 years older than Henry, Henry would be simply X minus 7, right? That's the relationship between the two ages. And then it says that in 5 years, now it's a different time, Albert will be twice as old as Henry. In other words, Albert's age will be double the age of Henry in 5 years. So what will be Albert's age in 5 years? Actually, it would be X plus 5, okay? And Henry's age in 5 years, it would be X minus 2. And within 5 years, the relationship between the two ages would be like this one here, Albert's, will be double or twice Henrys. So there is your equation already set up. Just an equation with a single variable. So you can solve for x plus 5 equals 2x minus 4. And what does this yield? That, here, x equals 9. The answer directly to the question, because we defined Albert's age at present as x, then this is the answer, 9. Okay? Now, what could be another possible approach? Some people get confused with this approach of trying to use a single variable only. You can always try two variables. For example, you might say, okay, why not say that, if you define several variables, like for different ages or different people's ages, one variable each, try to use the initial of the name so that you don't get confused. Don't use X, Y, or Z. Try to use, for example, Albert or Albert's age, A, Henry's age, H, actually. So you might say that, for example, the present age of Albert is, Henry's age plus 7 because Albert is older. Now, why to define the variables for the present ages? Because it's simpler and less confusing, right? For example, if the question were, how old will be Albert in 5 years? Don't define as your unknown the age of Albert in 5 years like the variable X, the age in 5 years. Define your variable for the present age and then what they're asking you in terms of the present age. For example, here, they ask you directly the present age. So no problem, this is our unknown, A. A equals H plus 7. Now in 5 years, this Albert will be A plus 5. And Henry will be, H plus 5. And what will be the connection between the two ages? This H will be twice this H. So you can use, like, for example, substitution. Since A equals H plus 7, you can say H plus 7 plus 5 equals 2H plus 10. So from this, you can see that H equals 2 if you solve for H. And then, since you define originally that Albert's age is Henry's plus 7, then it follows that Albert's age now would be 9 years. So that's it. Two possibilities, okay? The two are effective. It depends on whether you have some practice defining just a single variable. Whenever possible, you try to do the first approach. If you think it's a little confusing, you can use two variables and formulate a simple system of equations, all right? Let's move on. Let's see more examples. Let's try question 5. Okay, so here you can try. Clock is ticking. Okay, so how do we do this? It says Jay can run 60 yards per minute, right? Amy can run 120 yards per minute for the first 10 minutes, but then slows down to 20 yards per minute thereafter. If they start running at the same time, after how many minutes T will both Jake and Amy have run the same distance, assuming T is greater than 10? So this is interesting because we're given a variable already, is the time. We can say that, Jake runs lower than, more slowly than Amy at the beginning, but then Amy slows down, and, there must be some point of equilibrium, right, for matching the same distance. And we start from here. We want Jake's distance to equal Amy's distance run. So what is the distance Jake can run in terms of the time T? Since, its rate is 60 yards per minute, and this is T minutes, so in yards, okay, Jake's distance run in yards would be 60 yards per minute, right? Times T minutes. So these go away, and we have 60 T yards. Okay, let's do without the units. These yards, let's just omit this. 60 T is Jake's distance. What is Amy's distance run in T minutes, but T greater than 10? Okay, since T is supposed to be greater than 10, in the first 10 minutes, how many yards will Amy have covered? Okay, 120, the rate, multiply by 10. The first 10 minutes. So, you know, speed multiplied by time equals distance, right? So this is the initial distance run by Amy in the first 10 minutes. But then in the rest of the time, what would be the rest of the time if the initial 10 minutes passed? Then the rest of the time would be T minus 10. The rest of the time, Amy doesn't continue running so fast. She lowers her speed to 20 yards per minute. So this remaining time multiplied by the new and slower speed would be this. So this is the distance, okay? Distance in the first 10 minutes, while this is the distance in the rest of time. That is the total distance run by Amy. So now we can see that we have already set up, since this is an equality, we have set up an equation in terms of T. Okay, so 60T equals 1200 plus 20T minus 200. So what do we have? We have that 40T equals 1000. So what does this yield? Simplify, we get T equal 25 minutes. Okay, that's the answer to the question. So please, if you have any comments, any questions, any uncertainties, any doubts, please pray tell. Okay, now let's continue example 6. All right, here we have another one. You can try to formulate this one on your own first. Okay, so how do we do this question? The question asks about the number of scientists, okay, in that company. The number of scientists we can call X. This is our unknown, all right? Now, how do we connect X with the rest of the text in this question? This part is key. How do we interpret these statements that 1 microscope for every 4 scientists, 1 centrifuge for every 3 scientists, 1 freezer for every 2 scientists? How do we interpret this? Yeah, let's imagine for the moment, okay, let's assign some imaginary numbers for the value of X, that is the total number of scientists. Imagine that in the team, there are totally 12 scientists. If there is 1 microscope for every 4 scientists, and if there are totally 12 scientists, how many microscopes would there be? How would you find that out? What operation would you do? You would say, okay, 4 scientists, 1 microscope. 12 scientists, okay, I divide 12 by 4. So that would be 3, the total number of microscopes available. So actually, this expression here means that if you want to find out the total number of microscopes, the number of scientists you have to divide by 4. So the number of microscopes, this part, would be X over 4. Likewise, if there is 1 centrifuge for every 3 scientists, and let's imagine that there were just 9 scientists, how many centrifuges would exist? Simply 9 divided by 3, that is 3 centrifuges. So we understand that this second expression means that the total number of centrifuges is X over 3. And likewise, if there is 1 freezer for every 2 scientists, we need to divide the number of scientists by 2 in order to determine the total number of freezers. So the 3 expressions there indicate the different quantities of equipment, research equipment that exist, the total number of pieces of equipment if we add them up. That would be, according to the question, 52 pieces of research equipment. So we solve for X, we have the answer. Now, to solve this, what would be the best choice? Think about it. We need to eliminate in one step denominators 4, 3, and 2. So what would be best? What about if we multiply by the number that contains all of this, the least common multiple of the 3, that would be 12. So multiply everything by 12 on both sides to get rid of the denominators in just a single step. So what about this? The first product would be 3x, the second would be 4x, the third would be 6x. And this one would be simply, okay, your calculator, 624, right? So what do we have? 13x equals this. And of course, if you do the division, you can do it manually or with your calculator, you get 48 as the answer choice. So that's the answer. Well then, let's see another example. Here, move on to question 7. Let's try this one. Okay, so what's the answer? How can we formulate a solution for this question? Notice that we have, a mention of a number of books on a shelf, but we don't know what's a number. So let's call this 1x. It is more convenient to work with this total number than assign as our unknown the books that Lori possesses. Instead of saying that Lori's books will be X, let's define the total number of books as X. This will make it easier to get to the answer. So if Mark has 1/4 of the books, that means that Mark's books are this quantity. And Kevin would be X over 3. And according to the second statement, or the third statement says, Kevin owns 9 more books than Mark. So that means that the difference between the numbers of books they possess is actually 9. From this, we can determine X easily. Okay, multiply everything by 12. So you get here 4X like minus 3X. This equals what? Oh, sorry, here it should be like the other way around. The direction of this, difference is like Kevin is the one with more books. Otherwise, it doesn't make sense, right? X over 3 should be greater than X over 4. So multiplying by 12, like this. So you get actually 4X, take away 3X. This is 108. So X is this, exactly 108. So what happens now? What would be 1/3 of this? 1/3 of this would actually be here, X over 3 would be 36 and X over 4 would be 27. Right? So what does this mean? Since these two add to which value? This is the total number of books owned by Mark and Kevin. The difference is Lori's, according to this part. So that's the difference between these two. So the answer is actually 45. 45 Lori's books. Okay, so let's see one more example. Question 8. A group of friends wants to split the cost of renting a cabin equally. If each friend pays $130, they will have $10 too much. If each friend pays $120, they will have $50 too little. How much does it cost to rent a cabin? So what are our unknowns? Okay, it's true. The main unknown is the cost of renting the cabin. Let's call this C. But there is another unknown here. There is just mentioned a group of friends, and we don't know how many these friends are. So let's say this is like n. So considering this, what would be the interpretation of the statements? If each friend pays $130, that is, we multiply the number of friends by the contribution or the quota for each of them, this would be 130 times n, or n times 130. And this would be like $10, in excess of, the cost of the cabin, of the renting the cabin. This would be C plus 10. Okay? What if they pay just 120 each? That is, you would have totally this n times 120, but they would be short $50. So you have another equation. So now this allows you to solve easily for n, because you can do which method here? Elimination, right? Multiply this by -1 and this also -1. So you have 10n. Here, multiplying by -1, you cancel this and this. Here, multiplying -1 by -50, you get 50, which plus 10 equals 60. So what is n? 6. Since n equals actually 6 persons, then it's easy to know the cost of renting the cabin, right? You can just replace n in any of the two equations. Say, for example, in the second, you say 120 times 6 plus 50, that equals the value of the rent. So what is this? 720 plus 50, 770 would be the answer. Okay, so let's see another example. Of the 200 jelly beans in a jar, 70% are green and the rest are red. How many green jelly beans must be removed so that 60% of the remaining jelly beans are green? This one is tricky, so I'll give you 2 minutes, okay? Try this one out. Okay, it's just a matter of being careful when reading the statements, right? First, there are 200 jelly beans and there are 70% green and the rest are red. So, okay, let's try to make this clearly in a diagram. Okay, so you have originally 200 jelly beans. You have 70% green. So what would be 70% of 200? Actually 140. So the rest are 60. 140 and 60. You are gonna remove a number of green jelly beans. Okay? Remove, that means you take away, let's say X, and this number will also be deducted from the total number because you are removing the jelly beans. So what would be the new number of jelly beans, green jelly beans, when you remove those X jelly beans? Okay, you would have 140, take away X. This would be the green jelly beans left in the jar. And what would be the total number of remaining jelly beans after you remove X jelly beans? You would simply have 200, take away X. And what is the connection between these two quantities? It says that the green jelly beans that are remaining, right? 60% of the remaining jelly beans are green jelly beans. So what is 60% of this, of the remaining jelly beans? Is 0.6 or 6/10. This is actually the total number of green jelly beans left in the jar. So we have an equality. The green jelly beans or remaining jelly beans, green jelly beans, versus the remaining total jelly beans. So if you solve this for x, you have what? You have here this multiplying. Here you have 1200, 6x. So what is this? This and this, 200. 10x minus x, 6x, it's 4x. So x equals 50. And that's it, right? The answer to the question. Okay, so that's it. And now let's see a couple more examples. Sample 10. Try this one out, please. Okay, people. This one is indeed interesting. Actually, a little difficult. But you can always, beat these questions formulating patiently one equation per statement as you, advance reading. David and Robert have 120 baseball cards. So you know that there is, the number of cards that David and Robert have now, and then let's say later. So what is the number of cards David has now? Let's say it's D and Robert are, so the sum of these is 120, right? So we have one first equation, we might say this. What about the second statement? David gives Robert 1/3 of his cards and then 10 more cards. Robert now has 5 times as many cards as David. Okay, let's just change this a little bit. Let's call the cards they have at the end now, and let's call the cards they have at the beginning earlier, okay? So that we match what the statement says. Think about this. No matter how many cards David gave Robert, this is exactly the number of cards that Robert will increase his original number of cards. So let's call this quantity of cards being exchanged, between them, X. Now, what David will have is D minus X. And what Robert will have at the end, or now, is R plus X. So this is simply the deal. They are exchanging a number of cards. But what is X actually? How is X defined in the statement? This is the key part. X comes out from this. David gives Robert 1/3 of his cards and then 10 more cards. So this X here is being defined as 1/3 of the original number of David's cards, D over 3, and also 10. So that is X. And this X, we have to take away from David and add to Robert. So how do we formulate this? Take a look. You have that the relationship between Robert's cards now is 5 times as many cards as David has cards left. How many does David has left? This is it, what they are telling you. R plus X equals 5 times D minus X. Okay, so how do we formulate this equation here? Okay, R here is Robert's cards plus X, which is D/3 plus 10. And here 5 times David's cards. Take away the value of X, that is to say, D over 3, take away 10. So that's it. There you go with your two equations. Now, can you solve this? Multiplying everything by 3, you have 3R plus D plus 30. Here, multiply by 3, all the terms in the parentheses only. So you have 3D minus D minus 30. So open the parentheses, what do you have? You have this. Okay, here is 2D. So it's just 10D, right? Minus 150. Forget about this one. So that's it. Now you can solve this. You have 3R minus 9D, okay, equal to minus 180, or the other way around. And then you can solve this with this. Much better is to formulate this simply as substitution. You have 90 minus 3R. So rather say that D is 120 minus R. And so you can solve here for R and you will have 75. Okay, if you simplify. And that be it, the number of cards for Roberts. So these are some examples, right, that you can expect something like this in the SAT. Now, let's now connect the last part of the previous lesson in which we discussed linear equations, simultaneous equations, and then at the end, just slightly, we saw what is a typical way of representing lines graphically. So now we'll deal with this in more detail, okay? To represent lines on the XY plane, that is graphically, especially we use equations with two variables, X and Y, linear equations with two variables. You know, this is the XY plane with its division in 4 part sections or quadrants, right? And we define the signs in this way, okay? Horizontal axis, this direction, positive, negative, positive, negative. When we have a question like this, how would you solve this? In the XY plane, line L has a y-intercept of -7 and is perpendicular to the line with equation y equals -1/4x. If the point 5, C is on line L, what's the value of C? Okay, how can we do this? Actually, this is what you are expected to be able to solve using the right theory. So let's see. Okay, what theory do we need? First, remember that when you represent a line, okay, on a plane, you can describe the line using a linear equation with two variables. In this form, the typical form you're used to, or if you isolate variable y, you have this form, which is the standard form. When you have this form, it is extremely useful because these two numbers have meaning, no? This coefficient is called the slope, indicates something about the orientation of the line graphically regarding the two, you know, the vertical and horizontal axis. And this number here is the number that indicates where exactly on the vertical axis the line crosses. Take a look. Y equals m times x plus b. If you graph this line on the plane, exactly the point or the position on the vertical axis is this constant value b. How do you obtain that value? Well, the concept of the intercepts is this. The intercept on the vertical axis is obtained when you making the equation of the line variable x equal to 0, and vice versa. When you make variable y equal to 0, the value of x that you can isolate in the equation is exactly the position on the horizontal axis where the line crosses. So the y-intercept is always constant b, and the x-intercept is this value, -b/m. Okay, so you can calculate those if you know the equation of the line. If you know this form, you can isolate y and then obtain the exact or precise values of m and b. So basically saying, you know this equation, you know everything about the line. Okay, so let's see. So we use the definition of this linear equation in order to determine whether a certain point on the plane belongs or doesn't belong to the line. Because if the coordinates of the point actually make the equation of the line true, then you say that point belongs to the line, okay? Otherwise, it doesn't. Okay, so pay attention to this here. Let's see. For example, they give you this linear equation with two variables. What is the line on the plane that represents this equation? So use the intercepts. Find the horizontal intercept and the y-intercept by making, in turns, the variables in the equation equal to 0. For example, if you make y equal to 0, here x equals 10. So here that means that the place where the line crosses the horizontal axis is coordinate 10 horizontally. Now, vertically, you make x equals 0, so y would be -6 here. If you connect these 2 points, there is only a unique line passing over them. It would be something like this. This is the line that represents this equation. Of course, if you take the equation and isolate the variable y, then what happens? If you isolate variable y, then what you can notice here is that y would be this in terms of x. And then, oh, what happened? Yeah, here you can see that this coefficient multiplying variable x is called the slope of the line. And this other constant value is exactly this, the y-intercept. Okay, so the slope tells you some interesting information. The sign of the slope and the absolute value of the slope determine the orientation of the line in the plane. Let's see. Take a look at this. If the line a times x plus 3 times y equals 15, where a is a constant value, has an x-intercept that is twice the value of the y-intercept, what is the value of 8? Okay, take a look. So x-intercept twice the value of the y-intercept. How do we obtain the x-intercept? Making y equal to 0. So y equals 0, so a times x equals 15, and x would be 15 over a. What is the y-intercept? How do we obtain this? When we make x 0 in the equation, then y would simply be 5. So they are telling you that this, the value of the x-intercept, equals 2 times the value of the y-intercept, that is 5. So what is the value of a? Clearly, this one is 15 over 10. 1.5, the answer to the question. Okay, so another approach, what would be? Imagine that you say, no. I remember that we saw a formula where the x-intercept is minus b over m, y equals b. So if I give this equation the form of m times x plus b, we would have this. So take a look. Once you have set up the equation like this, you simply take a look at this. This is the y-intercept. And what is the negative or the x-intercept? The x-intercept would be this. Okay? X-intercept equals negative b over m. And y-intercept would be b. So what is negative b over m? It would be negative 5 over m equals 2 times twice, that is where the 2 comes from, 5. So exactly the same thing, right? Oh, where is this? Sorry, m here would be negative a. Let's just clarify this. M, which is the slope, is this part. So here, minus 5 over negative a over 3 equals 2 times 5. And of course, from this part, we also get the same, right? We isolate a and get 1.5. Okay, it's the same thing in the end. Let's now talk about the slope in more detail. The slope is a number that tells you, first of all, with a sign, if it is a positive slope, it means a straight line like this, that when you move from left to right over the line, you go up. On the contrary, if the slope is negative, that means that when you move from left to right, when you run over x, then you go down vertically. Okay, so this is a negative slope like this. Okay, for exactly these values, you have some angles. That means exactly 45. That means it's totally symmetrical, right? Same angle with the vertical axis, same angle with the horizontal axis. When the slope is 0, it means a totally horizontal line. But in this case, notice, if it is totally horizontal, then the equation would be something like this. Y equals 0 times x plus b. So this cancels, and you get simply this kind of equation. Y equals a constant value. And on the contrary, if you have a totally vertical line, forget about the slope. The slope is not defined for a vertical line. In the case of a vertical line, this is the equation of the line. X equals a constant value. Example, you have this XY system. And let's say there is a vertical line going through this negative horizontal coordinate, -4. So a line that goes exactly through that point has this equation. X equals -4, meaning all points on the coordinate plane whose horizontal coordinate is -4, while the vertical coordinate could be anything. Okay, that would be this. This is the equation for this vertical line over there. Okay, now what about the slope? How do we determine the slope of a line? You know, the slope you can see as this relationship, this ratio between rise versus run. Rise is the difference in altitude, okay? And run is the difference in the horizontal displacement. Okay, so if you take the ratio of these two differences in vertical and horizontal coordinate, you can calculate the slope. Now, notice this. When we want to approach the concept of the slope, we assume that the run is always positive. Why? Because we always say we are moving from left to right. Okay, if we are moving from left to right, when you calculate the run, always take the difference of, for example, this point versus this point. This is a positive difference, okay? But when you take the rise, the difference of vertical coordinates, only when the slope is positive, the rise will be positive. But if you are going down, if there is a negative slope, that is because the rise is negative. It's actually a decreasing in altitude or in the vertical position, right? So when you see, for example, a line like this, you can determine just from the orientation that this has to be a positive slope because you are moving in this way, in an ascending way from left to right. If it is on the contrary, you know, something like this, when you calculate here, rise versus run, okay, you have run here, but then the rise is negative because you are decreasing. So that negative rise over the positive run will give you a negative slope. So that's a way you can calculate if you are given 2 points. So let's see how we can use this strategy, having 2 points coordinates to determine the slope and the equation of the line. Take a look at this example. It says, the line showing the XY plane above passes through the origin and point A, B, where A is greater than B. Which of the following could be the slope of the line? Now notice something. If this is the line on the plane or of coordinates, here, this difference here, which is positive, would be the rise, and this difference here, right, would be the run. So what would be the rise? The value of the rise would be b minus 0, this difference, right? Because this point here is in horizontal position 0 and vertical position 0 as well. What would be the run? The run would be this one, a minus 0. So what would be the slope according to our formula? It would be the rise over the run, B over A. But notice, if you have a fraction like this, and they tell you that the denominator is greater than the numerator, what kind of value is this? Is it greater or less than 1? Do you think? Notice that if you have a fraction and the numerator is less than the denominator, in this case, B is less than A or A is greater than B, this fraction has to be less than 1, less than the unit. For example, 2 over 3 or 3 over 4 or 5 over 7, etc. So they are asking you which of the following could be the slope of the line. We know that the slope of this line has to be necessarily a number less than 1. So take a look at the answer choices. Which one is less than 1? You might say, okay, this one, but also this one. But do we really have here a negative slope? No, because the line is ascending from left to right. So the slope must be positive, but less than 1. So the only match is this. Okay, so that's a way how we use this concept of the definition of the slope. Let's see some more examples. Line M passes through points k, 7 and 3, k minus 4. If the slope of line M is 3, what is the value of k? Take a look at this. This is interesting. I have a line, and I know the equation of the line will be something like this. M times x plus the y-intercept. B is the value of the y-intercept. So how can I calculate the slope, the value of this M here? Okay, M at the same time is also the name of the line. Okay, so how do you calculate the slope? They are telling you that this is 3. So you have the equation 3x plus b. Can we find k? Okay, take a look. If the value of the slope is 3, then that means that the slope defined as the rise over the run would be, take the difference of this, right? Difference in vertical coordinates. Let's use this sense, okay? Take away this minus this. So k minus 4, take away 7, and then 3, take away k. And what do we have? K minus 11 over 3 minus k, and this equals 3. So we can solve for k, right? K minus 11 equals 9 minus 3k. So isolating k, 4k equals 20. And k equals 5. All right, so that's the solution. The value of k is actually 5. Okay, so let's see some more examples of this. We have, if a line has a slope of 1/3 and passes through the point 1, -2, which of the following points also lies on the line? What is the logic to approach this question? Well, how do I know whether one point belongs to a line or lies on a line? Only I can verify that if I know the equation of the line. Once I know the equation of the line in the form y equals m times x plus b, if I know this value and I know this value, I can insert the coordinates or the point here. And then if the equation becomes true, then that means the point belongs. So what do we need to do first? Determine the equation of the line. What is the equation of the line? Now take a look. We already have 1/3, okay, as the value of m. So what is left to do? Determine the value of the y-intercept. How do we do that? Okay, take a look. We know that there is this line that passes through the point 1, -2. Let's say this is 1 here, -2 is here. A line passes through this point with a slope of 1/3, which means the rise is 1 per every 3 units of, the rise is 1 per every 3 units of run. So it's like this, right? Something like this. Perhaps it is something like this. A line with a soft slope, okay? The angle of this is actually less than 45 degrees. So how do we determine this? Okay, we know that if this line has this equation, y equals 1/3 of x plus b, and it passes through this point, that means this point belongs to the line. If we substitute the coordinates of this point here, the equation must be true. So let's substitute. -2 equals 1/3 times 1 plus b. So what is the value of b? Okay, you can determine that easily. B would be -2 take away 1/3. So what is this? It's like negative, the sum of 2 plus 1/3. This is 7/3, right? So b equals -7/3. Now our equation is complete. Our line M equals y equals 1/3 of x minus 7/3. Let's now see which of these points makes the equation true. You see, -2, -5. You can just, instead of trying all the values here, you can do something clever. Take a look at the relative position of the line on the plane. Do you think this point belongs to the line? This point is in the 4th quadrant. You have another point in the 4th quadrant as well. One point in the, which quadrant is this? 4, -1. Okay, it's more or less in this quadrant. And then you have 4,10. But this is in the 1st quadrant. Is it possible? Maybe, maybe it is not. It doesn't really look possible. -2, substitute here, -2, -7, that is -9/3, -3. So if you substitute -2, you expect a -3. You don't expect, by doing this, it would be -9/3 or -3. So it means that -2, -5 is not a point. You expect a -2, -3. You can cross out these two together. So now try C. If you say y equals 1/3 times 4 minus 7/3, what happens with this? 4 minus 7 is -3/3, that is -1. So there is a match with this value. The correct answer is C. Okay, that's it. So it's important to determine first the equation of the line before you can evaluate which points belong or not. Let's try the next example. Which of the following could be the equation of the line shown in the XY plane above? What can we observe from this? For example, one interesting fact is that a slope has a definite sign. Only from the orientation, we can tell what is the sign of the slope. In this form of the equation, we know that the sign of this must be already known because of the orientation there. Okay, you can analyze for a moment before telling you how to get to the answer. What did we say about the sign of the slope? This is a descending orientation for the line. When we move, when we run, to the right, the rise is actually negative because we go down vertically. So we know instantly that the slope, the sign of this, must be less than 0. So cross out options B and option D because they have positive slopes. That doesn't match the orientation of this line. Now, can you determine exactly the slope without knowing exact points? Yeah, you could try to determine some points which are clearly mapped on this, grid, but then you can see clearly. Let's start from this. What is the rise? It is actually, you move 2 units to the right and go down 1 unit vertically. So what is this? What is the slope? We know it is a negative value and the rise is actually 1. You move 1 down and horizontally you move 2. Rise over run, remember? Rise over run. So negative 1/2 would be the slope of this line. The correct answer, option C. Notice that this exactly matches. This constant value here is exactly the position of the y-intercept. Let's see the next example. A line L passes through the points -2, 3, and 3, 13. What is the y-intercept of line L? Okay, let's follow our method. What is the method? First, let's determine the equation of the line. Once you determine the equation of the line, you have the y-intercept when you have it in this format. Once you determine this is the value that is the answer to the question. Okay, can you do that? Remember, if you have the coordinates of 2 points, the slope of that line passing through those 2 points is rise over run. What is rise? The difference of vertical coordinates. What is run? The difference of horizontal coordinates. Can we determine the slope here? Yes, we can. The slope equals, let's take the, if this is point A, this is point B, let's take B minus A. So 13 minus 3 divided by 3 minus -2. Notice I'm taking the same direction in the subtraction, B minus A, okay? So here you have 10 over 5, which equals 2. So that's a slope. We have this, y2x plus b. Now, all we need to determine is b, but how do we determine b? Remember something. If any of these 2 points, because the line passes through them, that means any of the points, the 2 points actually belong to the line. So the coordinates of any of these 2 points must satisfy the equation or make the equation true. Say, for example, this. 3 equals 2 times -2 plus b. So what is this? B equals 7. That's it. Answer to the question. Should you get the same result if you substitute instead 3 and 13? Of course you should. 13 equals 2 times 3 plus b. So b equals 13 minus 6, 7 again. Right? Yes. Okay, see another example. Okay, now let's talk about, some definitions for linear equations representing lines on the XY plane. There are several cases when we saw especially simultaneous equations. What happens when you have 2 lines on the plane that are parallel? That is, they never cross. Well, talking from the point of view of the equations, 2 equations with variables x and y that have exactly the same slope, they represent parallel lines. Example, y minus 2x equals 1, y minus 2x equals -3. If you give the form of the equation like this, isolated y on the left, then you would have y equals 2x plus 1, and here y equals 2x minus 3. So take a look. same slope. What does same slopes mean? That the orientation is the same, so they never cross. They don't form an angle between them. Okay? And that corresponded to the case, remember, when we try to solve these kind of equations, it's impossible. They contradict each other. How come 2x plus 1 equals 2x minus 3? It's impossible. Since both represent y, they should be the same. But there is no possible value for x that makes this equation true. So no solutions for this system. What happens when you have two lines that are represented by two equations that can transform into one another? Well, that simply means that you have two lines that are identical. So if they are identical, they, overimpose, right? One over the other. So this equation here, if you divide everything by 2, both sides of the equation, you get this one exactly. So they represent the same line in the end. So it's like, trying to solve this system of equations with infinite solutions. What happens when two lines actually intersect like this? If you have two equations, two linear equations with two variables, and those form a consistent system, that means that the solution of the system is actually the coordinates of the intersecting point of the two lines. And when these two lines intersect, forming exactly a right angle, that is a 90-degree angle, then something interesting happens with the slopes. The product of the slopes of these two lines must be -1. Take a look. For example, this descending line here is y equals -1/2 x plus 2. It has a negative slope. And the other has a positive slope. Notice that if you multiply 2 and -1/2, you get exactly -1. So that means that the two lines on the plane must be perpendicular to each other. Okay? So let's see what we can do with this theory now. If the lines y equals 3x minus 5 and y equals -2x plus 10 intersect at the point h, k, what's the value of k? Can you tell? Now, what happens? Remember what we said? If you have the equations of two lines on the plane, then this point here has coordinates that are actually the solutions, the solution for this system of equation. So if we want to know the values of h and k, what shall we do? We need to actually solve these two equations together. But here is interesting. We already have some special format that facilitates things. What can we do? We can simply equate this and this because these expressions both represent y. So it must be true, this. Solving for x, you would have actually this. So x would be 3, and 3 would be the value of the horizontal coordinate, okay? This one would be 3. So now, find the value, the corresponding value for y. Y, for example, using the first line equation, is 3 times 3 minus 5. So what do you have here? 4. Okay? So that's it. The value of k is actually this expression, right? 4. Okay, so let's try one more. One last, I believe. Yes. Now, take a look. Line M has a slope of 2/3 and passes through the point such. If line N is perpendicular to line M and passes through the same point 4, 3, which of the following could be the equation of line N? Interesting, right? Okay, you have all the tools to determine this. What should you do first? you have the slope already and you have one passing point. So it's easy that using this information, you determine completely the equation of the line. You have this equation. So it's only up to you to determine the value of B. Once you have determined the equation of line M completely, use the property of slopes to determine the equation of the second line. Okay, that's it. You can try. Okay, something interesting here is that you don't really need to determine the full equation of line M, because if you know that two lines are perpendicular to one another, then what must be true about the slopes? The slopes, according to the property we saw, must have a product of -1. So take a look. If this is the slope of line M, which number multiply by 2/3 gives you -1? It would be actually -3/2. So clearly, this cannot be the answer, okay? It must be one of the other three choices. So what's the equation of line N? Y equals -3/2 times X plus constant B. Let's call this constant B1 just to make it different from B, the other y-intercept for line M. How do we know this value? Because with this value, we determine the full equation. Okay, since the line N passes through the same point, that means this point satisfies this equation, makes it true. So 3 must equal -3/2 times 4 plus B1. So what is this value? Okay, you know, this is -6. So B1 would be 3 plus 6. So 9. Correct answer choice, this. Because the equation would be -3/2 times X plus 9. All right? Okay, now let's move on. Now it's time to talk about inequalities. Okay, how do we handle inequalities? Well, inequalities are interesting. You know, the questions you can expect in the SAT, maybe something like this. A cargo van delivers only 50-pound and 80-pound packages. For each delivery trip, the van must carry at least 20 packages, and the total weight of the packages cannot exceed 1,500 pounds. What's the maximum number of 80-pound packages that the van can carry per trip? Now, this is interesting because it's a maximum number. How are we supposed to solve this? Now, let's see some theory that can help us. First, here's another example of a question that we'll be able to solve using the theory that follows now. When we deal with inequalities, we need to be very careful about how we interpret certain statements, in word problems especially, and translate those statements to inequalities. For example, whenever you find these phrases, more than C, greater than C, where C is a numerical value, or higher than C, you can represent that with this inequality, greater than C, okay? The opposite, less than or lower than, is this. Greater than or equal to is this symbol, right? Greater than or equal, or at least C. Think about it, at least C. That means it could be C or more. So that's why at least C also translates to this inequality. On the contrary, when you say less than or equal to, or when you find the expression at most, that is C or less. So you translate that with this inequality symbol. No less than C means greater than or equal to C. No more than C means less than or equal to C. And so on. Right? So let's now take a look at some properties you need to be careful with. The basic thing you need to remember, because most of the operations that you are allowed to do when trying to solve an equation, you can do also when you solve an inequality, reduction of like terms, etc. But be careful, when you multiply or divide both sides of an inequality by a negative number, be it a constant or a variable, you need to reverse the inequality symbol after the operation. For example, an expression like this, very generic. A times X is less than B times Y. Okay, what happens if I want to isolate X here? Okay, isolate x, and what should I do in order to isolate x? I would divide everything by a, both the left and the right sides. So when I divide by a, what happens if a is a positive number? Well, what this inequality will become is this actually. So quite the thing you expect normally, right? But what happens if when you try to isolate the x here, you need to divide by a negative number a. If a represents a negative number, then when dividing by a, of course, you get on the other side this expression, but the inequality symbol must be reversed in the end. Otherwise, you would get a mistake. The same happens when you multiply. Imagine that here, I would like to isolate x. And in order to isolate x, I see clearly that I need to multiply both sides by a, so that I get x on the left side, and I get a times b times y on the right side. But okay, if a is greater than 0, no problem. You can do the same as in an equation. But when a is a negative number, say something like a over negative 2 is less than b times y. How do I isolate this x? I multiply both sides by negative 2, so here I get negative 2by, but then this has to change, like this. Okay, don't forget that. You only do that, reversing the inequality symbol, when you divide or multiply both sides of the inequality by a negative number. But if you add or subtract a negative number on both sides, you don't need to do that. Don't touch the inequality symbol. Leave it as it was originally. Okay? Then, what else? This is the most, tricky property and probably the most powerful property in inequalities. I'm talking about how you combine inequalities. Yeah, you combine equations by adding them, subtracting them, multiplying them, that is to say, correspondingly on each side, right? You can multiply equations, subtract, add, etc. But what happens with inequalities? Can you do all of that? No. You can only combine them by adding them, provided that they are aligned by the same inequality symbol. So I can say that from these true inequalities, I can derive a third true inequality, which says a plus c must be less than b plus d. But there is no way in the world that I can predict what would happen if I do this. A minus c in regarding to b minus d. What is this? Is it less than? No, you don't know. It depends on particular values of A, B, C, and D. It could be greater than, less than, or equal, any of the three. So don't subtract inequalities, please. Only add them. And you can only add them if they are aligned like this. Usually, applying this property, finding the way to apply this property correctly, helps a lot to solve questions like this. Remember? Let's see how to do that in a moment. Okay, so now it's time to do it, okay? How do we do this? Let's do this question. Please, try you first on your own. I believe most of you must have been tracking the statements one at a time, defining variables and everything. That's okay. Yeah, let's say that the number of 50-pound packages, okay, in this cargo van is X, and the number of 80-pound packages is Y. So, how can we connect first X and Y? There is this statement that says for each delivery trip, the van must carry at least 20 packages. What is the total number of packages carried by the van? X plus Y. So, this total number must be at least 20. We can represent with this inequality. The total number of packages carried must be greater than or equal to 20, at least 20. Now, what else? The total weight of the packages cannot exceed 1,500. What is the total weight? Well, the total weight is the addition of two partial weights. The weight of all the 50-pound packages, which would be X times 50 in pounds, and the weight of the 80-pound packages, that is Y times 80, or 80Y. This sum is the total weight, and this cannot exceed. That is, It should be 1500 or less. We can also represent this using this inequality. Now we have these two inequalities with X and Y. What is the maximum number of 80-pound packages that the bank can carry per trip? How do we find the maximum value of Y? This is what they're asking. How do we? Well, you may reason this in a number of complicated ways. Let me give you a little trick. Take a look. So, if I want to get the max value of Y, first let's obtain a range in the form of an inequality in terms of Y alone. How can we do that? Notice what happens if I place the inequalities, you know, like this, one above the other. What happens? Well, you see, how can I combine these inequalities? They don't have the same inequality symbol. But what if I multiply this inequality by -1? What would happen to the inequality symbol now? It would change and would align with this one. So let's do that. -x, -y is less than or equal to -20. Okay, but what good is this? I need to actually get rid of X in order to obtain a range only for Y. Now, what happens with this 50X? What would it need to cancel with this one? I just need to multiply the whole thing by 50, positive 50. So doing that, I get -50X minus 50Y is less than or equal to -1000. And now I'm ready to do the magic, right? I will add these two, provided that property number 3 of inequalities is being complied with, okay? We have two inequalities with the same inequality symbol, and we can add them. But this strategic Yes, this strategic sum will eliminate variable X and will get me 80Y minus 50Y, 30Y, less than or equal to 500. Finally, what I get is this. Y is less than or equal to 500 over 30, which is the same as 50 over 3, which is the same, you know, as 16.6 something, right? Yeah, approximately. Approximately. So what happens with this? That when I analyze the question, what is the maximum number of 80-pound packages that the bank can carry per trip? That is to say that the number of packages, that is Y, should be less than or equal to 16.6. So can actually the number be 17? No, because that exceeds 16.6, right? It exceeds. So if I want to obtain an integer value, that would be 16. And that's the answer to the question. All right, so let's keep moving. We have some limited time now. And which of the following integers is a solution to the inequality? Okay, this one is too easy for you. Can you try? It's just isolating X there in that inequality. Minding the three properties we just mentioned, right? So what is the answer in that case? Now, people, take a look. Let's isolate X. Take 7X to the other side, 7X minus 3X. Take -7 to the other side. So it would be -27 plus 7. So this is for X. This is -20. Divide by 4. You are dividing by a positive, so you have this. Oh, not quite the correct one, right? What happened here? What is wrong? So since X is less than or equal to -5, visualize this. This is your solution domain. Which number is in that region? Only A can be, right? -6 is the only one to the left of -5. That is less than -5. Very good. Okay, more people is getting encouraged to participate today. More ladies, actually, right? Okay, let's keep going. The quiz is coming. Number 2, if -7 less than or equal to -2x plus 3, which is negative less than or equal to 15, which of the following must be true? So how do we solve double inequalities? Take a look. Sometimes some approaches say that you need to split the two inequalities. Don't do that. Do everything all at once. Take a look at this. For example, first focus on isolating variable x only. So get rid of this one. How do we get rid of this? Subtracting 3 on each of the 3 parts. So subtract 3, -10, subtract 3, -2x, subtract 3, 12. Now, isolate x by dividing everything by -2. But because we are dividing by -2, we need to reverse all the inequality symbols. So -10 over -2, x, and here, like this. So what do we have? -6 greater than equal to x greater than 2. What is this? Sorry, 5, not 6. Sorry, this is +5. And this is -6. So x is, let's now rearrange this from right to left. -6 less than or equal to x less than or equal to +5. Which one matches option C? Okay, so that's the way. Just do it all at once, otherwise you will write more, okay, if you split into inequalities. Let's try one more example. To follow, okay, this one is similar to that problem of the cargo van. Try to do it in the same way, likewise, please. Okay, people, how do we do this one? Okay, here, several of you have actually tried, and this is good. Okay, there are several responses here. Let's see. Okay, according to this question, here we have that Jane must limit his daily sugar consumption to at most 40 grams. Okay, one cookie has 5 grams of sugar and one fruit salad contains 7 grams of sugar. So what is the total sugar you consume eating C cookies and S salad or fruit salads? Okay, if you ate C cookies, then multiply by 5 to have the total grams of the cookies. So 5 times C. What about the total sugar in the fruit salads? One fruit salad, 7 grams. So S fruit salads, S times 7, 7S. The total of this, the sum of this is the total sugar consumption, and it should be at most 40 grams. So no more than 40 grams. That's the meaning of at most, 40 or less. So less than or equal to 40. Option D. All right, that's it. Now, when we talk about two variable inequalities, how do we represent this graphically? If an inequality, you know, an equation with two variables, a linear equation, is actually a line on the plane, what is an inequality? It's a half plane. Half plane, what is this half plane? Remember that an infinite line splits the plane into halves. So there is an upper half or a half plane above the line and a half plane below the line. So one of these must be any linear inequality of the form like this, or perhaps like this. Notice that there is a difference if you use the less than or greater than symbol than if you use less than or equal to. What's the difference? But first, let's learn how to interpret and represent this in the plane. First, in order to represent and find the correct half plane, just try to find the corresponding line equation. For example, if they do give you something like this, replace the inequality symbol with equal, something like this. And using the method of the intercept, find the 2 points where the line crosses the axis. For example, take a look at this. What is the corresponding line? It should be 4x minus 3y equals negative 10. If I use the intercepts, that means when y equals 0, what is x in that equation? X would be negative 3. And if x equals 0, then what should y be for? So that is to say that these are the intercepts. So that's a line representing this equation. But we are trying to find this inequality. So just convert the inequality to this form. Either you will get this or this. If you get y greater than, then it is the semi-plane or the half plane above the line. If it is less than, y less than something, then it is the half plane below. Okay, that's a logic. Now, just remember there is a difference. If they tell you simply the symbol greater than or less than, remember that the semi-plane doesn't include the points on the line itself. While if the symbol used in the inequality is greater than and equal or less than and equal to, then the semi-plane or the half plane includes all the points on the line itself. So there's a little difference, okay? So now, what happens when we have a system of two inequalities? Since each inequality represents a half plane, two inequalities together can be visualized as the intersection of two semi-planes. For example, this inequality, which you know follows after the equation y equals negative x. So we know that this one represents this line, while the other with a positive slope represents the ascending line, this one here. So since this one has the symbol less than or equal to, that means represents all of this shaded part. All or everything below the line. That's the half plane. But the other inequality represents the half plane above, right? Above the line, the second line. So the intersection, the double shaded region, that represents the solution set for the double inequality. So how do we understand this? Imagine, for example, you have a system of inequalities that you want to draw here. Just reason like this. If y is greater than or equal than this, then this follows the equation negative 3x plus 1. But you know that negative 3 plus 1, that is the intercept of this line is here in 1. But the slope is negative and is steep, something like this perhaps. Since you have greater than, that means all of this, above the line. Now, what about the other half plane? You have y greater than 2x minus 3, but 2x is, you know, something like this. Negative 3 should be over here probably. This is the passing point. So the passing point is this. What about this 2? It's a little steep, but you know, in a positive slope, something like this. So greater than this, it's all of this. So you see this part here, like a double shaded region, that is the solution. It occupies part of the first, the second, and even the perhaps the fourth quadrant. Yeah, this little tip here. So actually, it is more precisely graphed here. You can see? Yeah, with a calculator, etc. Okay. So actually, which quadrants contain solutions to the systems? In other words, which quadrants are being touched by the double shaded region? This quadrant this quadrant and also this quadrant. This is untouched, the third quadrant. So the solution must be 1, 2, and 4. Okay, so that's it. That's how we interpret these questions about systems of inequalities, people. Okay, here there is one, and you will do this, as homework. Try to use the same approach as the cargo bank problem at the beginning. It's exactly the same. Very easy to do with that technique, trying to combine the two inequalities so that in the process, when you add the inequalities, one of the variables is gone. And then you get your range for just the variable that interests you in the problem.